Everyday miracles are something that we have come to expect in the world of AI these days. But did you know that even the space of data platforms is changing in unimaginable ways? In today's episode of the It Depends podcast, we get to learn about a new concept. It's called the Universal Data Processing Engine. This term has been created by an exciting new startup. It's called DataPelago, and it is my honor to have its founder, Rajan Goyal, talk to us today about this concept. Rajan, welcome to this episode.
Thank you, Sanjeev. It's a pleasure and very nice to meet you.
Likewise. So, before we get started on why DataPelago, what is it, what are the benefits, and all of that we will dive into, can you please give an introduction about yourself?
Sure. Well, happy to do that, Sanjeev. This is Rajan Goyal. I have been here in the Valley Bay Area for last 30 years. Like most of us came for my grad school for CS. First 10, 11 years worked on building large enterprise grade products, learned a lot. Most importantly, hardware, software co-design. But that's when I switched to building domain specific processors. So my first startup, which I was part of, we were building MIPS and ARM-based processors for specific domain. Now we talk about this buzzword accelerated computing, but the actual pioneer work was done during my first startup. And then we were very successful. And then continued my journey to the second startup where we built coined a term DPU, data processing unit. So if you look at my past work for 15 plus years, all the modern cloud infrastructure is built on the technologies that I participated in. So in modern infrastructure about moving data, and which we will talk in a subsequent topics, but that's where I spend my time doing hardware, software co-design, building domain-specific processors, doing systems work, and so on. And that's my background. And then that led me to our current journey at DataPelago, which I'm happy to talk about.
So, great. Thank you so much. Such a pleasure. Why did you start DataPelago? What was the problem that you encountered and you have set out to solve?
Yeah, so my journey, Sanjeev, to DataPelago has been, I would say, non-traditional as other data companies or entrepreneurs or you can say founders start with. As I said in my introduction, came from deep infrastructure background. We were building processors, for security, for deep packet inspection, for compression, data movement, and lastly, it was about data movement in the data centers, right? So idea was that the data center has gone through a shift from a hyper-converged systems to now what we call composable and disaggregated infrastructure. And when all you have your CPU racks and storage racks and the GPU racks and now even memory disaggregated, and you dynamically compose with the help of software a SKU of server that you're looking for. That's kind of the modern infrastructure is built with that. Once you do that, that requires a fundamental technology to move data between compute to compute or storage to compute and compute to GPUs and so on. That's what I built in. I was part of that, you can say, work in my previous decade to move data efficiently in the data centers. And hence came the term data processing unit or the DPU, which has now become a third pillar, if a computing pillar. CPUs, GPUs, and DPUs are what are mainly the workhorse in the data center. So coming back to your question, so in my previous life, we were solving the data movement problem. So it dawned upon me that now we are able to move data efficiently. That means now the next puck or the bottleneck will be in the data processing itself, because not longer the IO is no longer the bottleneck. Whether it's within the node or across nodes with internet, Ethernet, or with PCIe bandwidth improving. So hence that was how my, as an engineering mind, led me to, okay, where is the puck moving as far as the bottlenecks? It turns out to be data processing. And it is also from business point of view, very, very interesting. People spend today like almost 180 to $200 billion on data processing using SaaS or IaaS or PaaS combination of that. So it's a huge market. And as data centers are shifting with this accelerated computing, it kind of was obvious that something has to be happening, right? So that's what led me to the world of data or the DataPelago. And we formed kind of a company to venture into that to solve that problem. So that's what led to the DataPelago.
So, yeah, go ahead. No, please.
It's okay. I mean, I was just going to add one sentence that
Yeah.
subsequent to that, you can say that data processing can be broken into high level. If you at 100,000 feet level, either you can process through neural networks, where that's what training or inference workloads are. But there is another complementary piece, which is actual traditional data processing, whether it's in the analytics space or ETL or whatever, or even emerging for the data or AI space. That is still was left in the previous decade as far as the infrastructure is concerned. So hence we formed DataPelago to disrupt that. That's kind of the
I
longer
see.
answer how I led with it.
So we will dive deeper into DataPelago because we are, I love how you started with your background, the history, because what you're saying is that the first problem was the networks are very slow, and hence you created the DPU, data processing unit, and so that was to solve the network problems. In fact, I remember the advent of big data was in my mind when Hadoop came out. And Hadoop design was to co-locate, compute, and store on each of the nodes, but distribute the nodes
Right,
because it was the networks were very slow.
right.
So you went from network optimization to, in fact, you were telling me once that you were trying to create a God processor. You had a name for that, PDU or something, right?
Right.
What
Yeah,
was?
yeah. That's correct. I mean, I think picking up on what you said, absolutely. Industry went through this. I think the term was coined by Nutanix, hyper-converge, which is
Hmm,
what there was a building block for Hadoop kind of systems, where you have your CPUs and local attached drives, whether spinning drives or now flash drives connected to the in a box, and then you copied 100. That's the scale out was and the homogeneous server scale out and so on. But as what turns out that so two parts of the question, Sanjeev. So bear with me. I want to address the first part also.
okay.
But it turns out that every application required a disproportionate ratio of the compute to storage, right? Some applications need a certain way, some application needed certain way. Hence, there was need to disaggregate. Otherwise, if you
Hmm,
have a fixed proportion of CPU to storage ratio, right? And if you need to scale storage only, you're stuck with the same
correct.
cookie copying out, right? So
Yeah.
hence the industry wanted to disaggregate rather than local attached drives to network so that you can
Hmm,
scale storage independently and compute independently and use it. And that led to where we are right now with the notion of data lakes and so on. But
so
the
yeah.
yeah,
So what I remember you were telling me one. So once you solved that network
problem,
bottleneck, then
right?
the problem moved up to the
To the
application layer.
exactly to the processing of the data. Now you can move data from storage to compute, but now the it's you want a it's a distributed system, Sanjeev, that we are talking
Yeah.
about, right? You want an impedance match. So earlier it was data movement was a bottleneck. Moment
Hmm.
you solve that and disaggregate, now the compute was falling behind because it's well documented now.
Yeah.
CPUs were not improving every 18 to 24 months as they used to be. So because of Moore's law flattening and so on, so hence the compute was becoming the choke point in the
Hmm.
big data processing, right? Now coming back to the second half of your question that you asked, if you want to think about, if you want to apply yourself to the world of data with the new
Yeah.
assumptions, with the new data movement, and new technology and whatever, and if you look at the workload is also changing, the data is changing,
Hmm.
and patterns are changing. So then the uniqueness I can say that we bring to the table is because we think always from processor point of view. Okay, what should be that God processor for this
Hmm.
workload? If we are
Hmm.
given a clean slate, then you would want to define a God processor for this workload. Now, in order to do so, you need to know three things. One, you need to know the workload intimately, like what my data processing looks like, what are the access patterns, memory accesses, compute ratio, and so on and so forth. The second is what is the infrastructure available today,
Hmm.
gaps between data movement to computation. And third is what technology you will do, right? Processing technology and so on. So because I had the background on the infrastructure side
Hmm.
and some of my team members intimately knew about the data workloads itself. So we as a team had a good sense of if we were given a clean slate, what that God processor should look like for this
Hmm.
problem, right?
Hmm.
Ignoring the business, let's say you are given infinite time and infinite resources, what should that God processor be? And hence we first started with that, with what internally called PDU, programmable data flow unit. It has to be programmable
Hmm.
because you can't hardwire it. It's every function workload is different. It has to execute data flow graphs, and unit is like processing unit. So hence we came up with that. But that was our first, you can say, starting point. What should
Hmm.
that? And then obviously the next step could be, given that God processor, which should be
Hmm.
the make it 100x better than today's technologies, whatever. Then the question is, how do you go about it, right? Whether
Hmm.
you build that God processor yourself, we have done it in the past for different applications, build a custom processor, programmable and so on, either ARM based or RISC-V based these days. Or other option could be, can you realize that using today's off-the-shelf technologies, right? So hence, we went through that journey to figure out what makes sense from today's technology, from performance per dollar, availability wise, time to market, and so on. And hence, we can talk a little bit more. But that's answer to
Yeah.
your question about the
Got
period.
it. So you went from network optimization to this got application domain specific application performance enhanced to now we're talking about a higher layer at the application at the business optimizing the data platform itself. That's what you are building.
Right.
Okay, so let's talk. Let's give some some uh, practical view as to what you're building. So can you talk about some real life use cases where your technology is being used? Which customers are using it? What benefit are they getting?
Right. I think there is a, if I may expand a little bit preamble to that question, Sanjeev,
Hmm. Yeah, sure.
because and then I'll get to the use cases. The what I wanted to set the answer your question with the context is that, this is not a new world.
Hmm.
World of data, there have many successful platforms already built. All enterprises today have more than one platform deployed into their internal systems, right? So whether it's a Teradata of the world, or Redshift, or Snowflake, or Databricks, or streaming, or real time, you name it, there are. In fact, that's a problem itself, because now you have silos of various solutions, because there is no one solution for all, right? But you need to still respect that ecosystem,
Hmm.
because if you have to realize that, okay, enterprises have legacy applications written for existing data platforms, and underneath the infrastructure is changing, as we just talked about, like processors are changing, data centers are changing. It's moving from a general purpose processor to accelerated computing processor, and so on. So if you are gonna disrupt this, have some disruptive product, you don't want to disrupt the ecosystem, right? You
Yep.
don't want to disrupt the customer. So
Yep.
hence, we came up with an insertion technology with techniques, which we can talk about it, the what we call universal data processing engine, or UDP, and how do we insert. But we didn't want to, the idea that, if I want to summarize in one statement, our objective or the mission is, we want to give the benefit of accelerated computing to all existing data platforms which are written 10 years back or in the last decade, right?
Yeah.
How do we seamlessly insert into that without any change in the application? If we can do that, then that's like the God insertion also, right? That's ideal insertion, because you can bring them up to speed with today's infrastructure. So that's kind of the approach we took. Now, coming back to your question, now if you extend it further, there are a few more holes to fill from that to the question. But the question for use cases, then I break it into two parts, Sanjeev.
Hmm.
One, today's problem, then ETL, business intelligence, BI use cases, those are all valid. And then the what I call tomorrow's problem, which is also coming very at fast paced close to us, is data processing for AI, right? So that's when we're talking about multi-model, unstructured, semi-structured data. So those are also the use cases that we want to address, right? So those are the two,
So
the high level I want to say.
I love this the way you've classified it. So now we're talking about use cases. So you're saying that you look at use cases in two ways. Today's problems are the brown field, what is already running, and I think your value proposition for those are how do I reduce the total cost of ownership of what already exists?
That's correct.
Okay, your second
That,
use
that,
case, I'll finish this and frame it, and then you can dive. So, the second use case is tomorrow's problem is what is coming on horizon and is greenfield, and those are things like new generative AI workloads, training models, inferencing, uh, I may even add crypto because crypto is coming up. I was in Davos a month ago, and crypto was such a hot topic there. So those are tomorrow's problem where it's not clear cut. Like today, we are handling structured data, but we are moving more and more into the space of unstructured, semi-structured data. So is that how you're categorizing the use cases?
That's correct. I mean, high level, I mean, when we do, in a startup journey or
Mhm.
otherwise, you always have to be, uh, aware of your insertion and being successful with customers at incremental fashion, right? You can't boil the ocean in one day. So that's
Yeah,
kind of the pragmatism
I see.
of the which use cases to handle. So that also comes into the startup journey rather than
Mm,
trying to do thing. But at high level, yes. Actually, there is a very insightful comment you make in your own question that if you say you want to address the brownfield market
mm,
and bring them up to speed and give the benefit of accelerated computing, what will be the value proposition? Because
mm.
customers are already solving today's
Yeah,
problem. They're happy
correct.
with
They
that.
have a solution.
They
Yeah,
have a solution. So
yeah.
if you tell them that I'm going to run the job, let's say hypothetically 2x faster, it may not be interesting because they're
Mm,
happy, SLAs are getting mad. Nobody wants to tinker with existing system if it's
yeah.
not broke, right? But as you rightfully asked in your question, the value proposition, if you can reduce the cost without changing the application, then all of a sudden it becomes very interesting.
Mm,
Because now with that budget, if most of the CIOs we talk to, they have aspiration
yeah.
to grow into this modern AI and data processing world because
Mm,
that's the future and they see the value. But the budget sometimes constrain them because they have to keep the bread and butter alive and then get another budget for that. If we can help them save the TCO on the current bread and butter and
mm.
they repurpose that thing for the AI workloads, then it's a win-win situation for them. They are now the CIO or the CDO and a data product head is actually
Yeah.
motivated to save money so that he can invest into the future, right? So hence,
I can see that. Yeah.
so for the brownfield TCO savings is the value proposition, right?
Got it. Yeah, I can see that because, customers are saying, wait, we already ripped and replaced by going from on-prem to cloud. Now you're saying that we should replace everything. I mean, re-architect everything. That's not going to work. So you want to maintain that the user interaction, but by insertion, I think you mean like a layer of abstraction and then uh, give lower the TCO without changing the business applications.
That's exactly right. I think there is, since you brought about this, just I think probably Sanjeev, if I may use this moment to clarify
Yep.
the
Yeah.
insertion part, right? So
Yeah.
if you break your data platform as, let's say, three-layer cake,
Hmm.
okay? So just to give a mental model, and those some of those layers were work of data lake house kind of paradigm, right? You have
Hmm.
already disaggregated your storage from your engine, and then on top of engine is your application layer. So let's
Correct.
say imagine this three-layer cake, right? So
Yep.
the industry already went through this open table formats like
Yep.
Iceberg, Delta, or Hoodie, this or lakehouse concept of data lake with execution engine. So that
Hmm.
bottom two layers of the cake were already disaggregated, if you will,
Hmm.
right? With the
Hmm.
storage separate from the execution engine. So what the problem statement then becomes with building upon this very fundamental paradigm shift that already is happening and is very at fast pace is that what if you can now replace the middle execution engine which is now built for modern infrastructure. If that picture is clear, that is what I meant by insertion of UDPE between those three layers. Is the UDP becomes a middle layer, right? Now it's an engine
Hmm.
running on the storage on the using the disaggregated storage with open table format or multi-model data running on modern infrastructure, which is accelerated computing, GPUs, FPGAs, and TPUs, and there are hundreds of, not hundred, at least tens of computing element emerging. So if you run on that, now that UDP layer is what you're building at DataPelago, which makes it universal, right? So now you give the
Yeah.
benefit of existing application. I hope this
Yeah,
mental model.
no, no, this is clear. So we are literally stepping stone, like going from, understanding. I completely agree with you. I learned something that surprised me at AWS reInvent, where I saw you last time in December. And what I learned was that just a few years ago, AWS introduced Graviton, their ARM-based chip,
Right.
and the amount of compute on Graviton in December of last year was more than all of AWS in 2019. And I'm also hearing a lot about how ARM-based chips are becoming sort of the de facto standard. So you got CPUs, you got GPUs, you got RISC, CISC, you've got ARM-based. So there are all these things. So I see where you're going. I want you to dig a bit deeper. When you say universal, what do you mean by that?
Yeah, good question. Yes, let's spend a couple of minutes on this. So some of it is going to be repeat, but let me just set the context, right? So realization, the observation is what you just started in the question that, in the previous decade, whole industry kind of went with standardized on single server, which is x86, Intel or
Hmm.
AMD. Everybody was
Right.
just using, right? In the cloud, and that become our workhorse for industry for many, many years.
Hmm.
And the only card was to scale out, right? So just scale out those servers.
Yeah.
What has happened is we are entering an era of accelerated computing or heterogeneous computing, right? So as you said, processors are changing from in x86 to ARM based, whether in-house, mostly like Graviton as an example. But most importantly, Sanjeev, there is a CPU plus something else now, right? CPU plus GPUs, CPU plus TPU, CPU plus FPGAs, CPU plus Inferentia or Trinium from AWS. So there is something else added along with CPU because CPU alone is not enough for these workloads. Okay, so that's the realization. So that's one part. The second part is that data is changing, right? You have structured data going to a semi-structured, unstructured data, and Gen AI is the poster child for that application, for that kind of data. So, so the idea was what that engine should look like, and maybe there is a room to create a new category. Right? That's what we kind of started with. So hence the coin the term universal data processing engine. So what is universal about it? Data processing engine is obvious. It's universal for three things. One is that it can run on any hardware. And now that any is not just the availability part, but also the right hardware, right? You
Hmm.
want to run, whether it's run in GPUs or CPUs or FPGAs, what is the right computing element? Because it's not clear that all of them are Turing complete, right? So you can run any workload on CPU or GPU, but where is the right sweet spot,
Yeah.
performance per dollar, or where is the efficiency? So that's kind of one part of this universal data processing engine. The
Hmm.
second part is you want to process any kind of data, right? Even though most of the analytics products or the data products, we're dealing with tables and structured data. But what is the challenges required to handle unstructured, semi-structured data in terms
Hmm.
of data movement, in terms of data representation, in terms of what kind of operators are required to process that data? That brings a new dimension to the engine, right, in order to handle that. And the
Hmm.
third part of universality, Sanjeev, is which we talked in a previous discussion about the brownfield. You have Spark, you have Trino, you have
Hmm.
Flink, you have other data products emerged over last decade, and can you give the benefit of this to those? So if you think about those three aspects, any hardware, any data, and any data engine or any
Hmm.
platform available, if you can somehow add value using those three, that's what we call a universal data processing engine. So that's a very clearly defined definition. And our first product is the UDP, which handle more than one engine. It handles more than one hardware and process multimodal data. So that's the definition of UDP, Sanjeev.
So if I start from bottom up, it's any hardware, CPUs, GPUs, FPGAs, ASICs, then it's any data type, structured,
That's correct.
unstructured, and then
Yeah.
any engine. And what are
Yes.
the engines you support today?
Today we support Spark and Trino, but we
I
would
see.
and we also support Ray, which is not an engine but a distributed framework. So we
I
we
see.
support.
So Spark, Trino, and Ray.
Yes.
So uh, okay, so that makes sense. And what is the benefit that customers are getting? First of all, let's talk about where does UDP exist? Like, how is it deployed in the architecture, in the stack? Like, where would people put UDPE? And then I want you to talk about like what benefits can we expect?
Yeah, good question. So, one is that you always want to be careful, Sanjeev, about insertion, who is the target persona.
Hmm.
In our world, there are two personas that you think about. One is people who are using it, data scientists or analysts who are using this platform. And
Hmm.
one is the people who are deploying them, who are responsible for life cycle management of, right, for these platforms. So from both of this point of view, people who are creating clusters, who are deploying it and so on, that from their point of view and from the user point of view, we want it to be as transparent as possible, right?
Hmm.
So there is
Correct.
no change in their behavior or learning. So
Yeah.
so there is a so now, given that context, given that objective, we deploy UDP as a, think of like a plugin into your existing system, right? Think mental model is, you have your platform, it attaches as a sidecar or the training wheel at steroid, right? So it attaches to that, and as a result, it influences the runtime of the platform to do two things. One is it uses the modern infrastructure available in the cloud because it's all in the cloud available. And secondly, it starts processing the other data that is probably not possible today, right? So those are the two things happen. And application point of view, nothing changes. If you're using either
Yeah.
class tools, uh,
Right.
you can name it Looker, Tableau, or whatever, or
Right.
notebooks, or any other workflow management or whatever, nothing changes from the surface. So that's how we insert in that. And the benefits you see is the
So
second part of the question.
can we hold on for just for a second? We'll come to benefits in a second. So what you're saying is that so UDPE gets installed in a customer stack and it's in their VPC, right? It's BYOC, correct?
That's
So UDP is available as a Docker container, gets deployed in customer's account, is transparent, and so now if I'm running whatever jobs I'm running, what does UDP do? Like, does UDP now say that, oh, based on this Spark job, the amount of data you're consuming is too big, so you need a bigger node, or maybe you don't even need CPU, you need GPU or FPGA. What is UDPE's? How is it helping me get higher performance and scale?
Yeah. So whether it's containerized or whether it's a VM is a next level technology, and UDP itself does not put that restriction. Just to clarify on that part of the
Okay.
question. But the second part is, it is UDPE. In order to answer that question, Sanjeev, I have to kind of break UDP into
Hmm.
further components, if I may.
Okay.
Can I
Yes,
give you?
please. Yeah.
So UDPE, you can think of like three layers, modular layers of that.
Mhm.
If you double click on the UDP, we do three different layers, okay? And let me explain again bottom up. And the bottom up, the first bottom layer is what we call data VM. Okay, that's our term that we have coined.
So data virtual machine.
It's data,
We-
but exactly, it's a data
yes.
virtual machine, as
Okay.
the name suggests. What's the problem it solves? It's actually very similar to what Sun invented, Java virtual machine,
Yep.
or even for that matter, VMware also had hypervisor. The problem was, how do you abstract the low level hardware
Mhm.
details from the upper stack, right? So we already concluded that there's a heterogeneity in the processing element, whether it's a NVIDIA
Yeah.
GPUs with CUDA program environment, or AMD GPUs, or FPGAs, or TPUs, or others, right? Or CPUs with LLVM and whatnot. These are all different programming and heterogeneous servers. Our intent was that let's virtualize it, let's abstract it out so that the upper stack doesn't care. So that's the bottommost layer of the data of the UDP, is what we call data VM. Basically, it's a virtual machine with its own domain specific ISA. That's the term we use in processor world. It's instruction set architecture, which is domain specific, and then it maps at runtime to the underlying infrastructure. That's the bottom layer of the UDP.
Hmm.
Then if I go to the first layer, I'll introduce the second layer in bit. The very top layer of UDP is that you want to support multiple engines, right? Whether it's a
Correct.
Spark, Trino, or whatever. That means there has to be some way to represent their intent into some common IR, some common intermediate representation. And
Hmm.
that is what the first layer is, to convert whatever that thing is to common IR, or takes the common IR and then convert it into data flow graphs or physical plan or whatever. That's a common term used in the data world. That's kind of
Correct.
the top layer.
Optimizer, like cost-based
Like
optimizer,
optimizer, but
yeah,
it's now more infrastructure aware. One is a
infrastructure.
cost
Yeah,
based from the data aware, but this is now infrastructure aware.
correct.
Now
Got it.
you have these two layers. Bottom layer is execution layer, and the
Yeah,
top
data
layer is
VM.
giving you tasks. Now you need one more layer in between. Just again, we picked the from the system space. You have VMs, you have app, which we call the top layer. That means you need an OS layer in between,
Hmm.
right? It's a marriage. It marries the your task or the physical plan created by the data app or the upper layer and your n number of data VMs running. So it marries it at runtime, meaning that it picks the right computing element. It is possible that some operator is better in GPUs, some better in CPUs, some are better at FPGAs. So it runs that runtime mapping and it schedules them. Also being aware of data affinity and you don't want to move data to the compute. There are some high level principles. Move compute closer to data. So some of those using those principles, we have a intermediate data OS layer. So those are the three layers of UDP: data VM, data OS, and the data app. And that's what gets inserted as a side wheel into your existing platform. And all those three layers help or augment at runtime the processing of your queries so that it runs efficiently on the infrastructure as transparently as possible. I
Okay.
hope that picture is clear. Yeah.
That is very clear. So let's talk about benefits. So we know UDP can help optimize and run things more efficiently. But you had said earlier that just because you can run something 2x the speed is not compelling.
That's correct.
So what is it? So can you give us some benefits of why would anyone put UDPE in place?
I think, yeah. So one is, again, a practical from enterprise point of view, right? Your objectives change where you're inserting. If you're inserting into brownfield applications,
Hmm.
then your objectives is to reduce TCO, right?
Yeah.
So, and now in today's world, Sanjeev, your cost it's all consumption-based model, right?
Hmm.
That's a business model. So consumption of compute is one way to drive the cost. And if you reduce your consumption of your compute hours, then it directly translates to lowering your TCO. So that's kind of the high level model, right? So because we run the jobs faster, or let's
Hmm.
call it efficiently in the modern infrastructure, that translates to the TCO savings for one constituent of the customers. The second one is that it also enables new use cases. You can meet your new SLAs, or you make things which are not practical today because of the speed or the performance that we can deliver, right? So those are the two ways, depending upon what is the target constituent, we can enable in that, right? So
So, Rajan, one thing you had told me earlier over the last few weeks when I saw you, something that struck with me was you were telling me how like the open source community is very strong, as we know, but it's kind of, I'm my own words, not your word. It kind of got abandoned by these large companies who went and built proprietary extensions that were much faster, more efficient, had more bells and whistles. So what you're trying to do is take that open source because that's where you get cost savings, but now provide this performance benefit. So you get double the benefit. A, it's open source. You're not paying the proprietary fee of the provider. And secondly, it's a more efficient utilization of resources.
that's exactly right. I mean, just using the way you frame the question, yes, you will see that for the right reasons from commercial point of view, whatever performance improvements those vendors have or had were not put into the open source ecosystem, right?
Hmm.
So hence there's a growing gap between the performance or the cost characteristics of the open source systems versus the corresponding proprietary ones, right?
Hmm.
Now the realization is that just to make it more specific, those open source systems which were written 10 years back in Java with running on Java virtual machine and so on are still running like that, right?
Hmm.
Obviously, there is a and other proprietary systems went through multiple generations from converting from Java virtual machine to C++ or to vectorization now to the GPUs and FPGAs. They are on the journey to that. But the open source is left behind. There are open source
Hmm.
initiatives also to fix those. What we are doing is that we, with our technology, want to leapfrog or enable those open source ecosystem to keep up with the new infrastructure, right? The new infrastructure looks like GPUs, FPGAs, so on. And how do we give the benefit of that? That's exactly what the UDPE or our
Hmm.
DataPelago platform enables us.
So it's a marriage of open source Spark. You can now run it on a GPU if the use case demands it. Is that
That's
correct?
that's exactly right. That's
Okay,
good.
I think this is great. Can you talk about actual real life use case? Like, can you name a customer and tell us what benefit they're getting?
Um, yeah, so I think let me say a few like verticals that we are in, right? So I'll start with that. Obviously, it is a horizontal platform, so not limited to a specific
It's industry
industry
specific. It's
wise,
not industry specific.
not industry specific.
Yeah.
But
Mhm.
yes, in a we are a startup. So in a startup journey, you look for certain industries or the verticals who
Mhm.
can adopt new things quicker than the other. So that probably goes into how in which order we are approaching the verticals. But having said so, it's a manufacturing, like semiconductor manufacturing, retail, or financial. All those these are the massive large use cases you can find, or industries domain verticals you can find where we are finding a success there. Now, if I double click further one more lay down, use cases are, as we talked in the brownfield, classic ETL, and also the engine itself also dictate, right? There is already a mapping of what engine is used for what. I mean,
Mhm.
primarily Spark is used for data engineering. So then you get those kind of workloads for ETL and so on. People are also using for BI, but primarily it is what. And if you are in a Trino world, it is used for other dashboards or ad hoc queries and so on. So that itself, there is a you can say a fixed mapping of the use
Mhm.
cases to the engine. So that's there. But given the power of the UDP, we also sometimes extend the scope of the existing engine so that they are not doing it. So some example would be, again, without naming a customer, if you're using some expensive data warehouse where it's expensive because you need to run it for performance at least. If we can give the power of the UDP to, let's say, this open source system, and we still give the similar or better performance without requiring ETL into this proprietary format and keep the data into data lake and separation, then that's a very interesting proposition from
Can you
the
quantify some of the benefits?
yes. So the actually I can that precisely answer that. So in this case, if I look at the engine capability, right? Then we are talking about an order of magnitude performance boost from one engine to another engine, our engine compared to what is in the market, right? But if I translate to the when you run at a SQL level or a Python level or a PySpark level or whatever is the interface, then the existing gaps, an example I gave you, were already like 2.5x better or 2 to
Mm.
3x better. And if we can bridge that gap by our technology, and then there is people don't see a need to go to a proprietary data warehouse, they can still use a lakehouse paradigm, right? So if a lakehouse paradigm is a pretty powerful concept because now you have a disaggregation of storage from the compute or from data from the engine, but if the performance gaps are not filled, then some applications will not be adaptable to that, right? So our technology allows people to do so. So that's kind of
I
one way
see.
to look.
Rajan, I'm happy with all this technology that you have built and how you are taking these open source products, the Spark especially, and you're making them as performant, if not more performant, like 2x the performance that you would get out of the box. But for a category to be successful, there have to be other players as well. Are there other companies? I know this is a sensitive topic because I'm asking you about who else is doing this stuff in this industry.
It is a, I would say when we started, in fact, people were rightfully there were you would see blogs about why the status quo is good enough, right?
Mm.
Like why something like this is not. So but now where we are, it whether it's the hyperscalers, whether it's other data providers, data platform providers or new startups. So there are a realization that the data processing itself is ripe or ready to be disrupted with, or can take advantage of this modern infrastructure which is coming, right, in the cloud. That is now a kind of an acceptable norm. So now in that, given that shift in the industries, we can say acceptability of this new approach, there are startups. I don't want to name them, but there are startups who started similar time frame who are doing
Yeah.
that. And then, I mean, it's not like it's all, and people who are hyperscalers, I'm sure, who have their own data platforms, companies like Databricks, or they have publicly announced that they will want to use Photon or Photon with the GPUs and so on. So it is now a writing on the wall that this has to be done. The data processing has to be done with the has to align with this new shift in the infrastructure. Otherwise, the last card, as I said earlier, was the scale out. So you cannot just continue to scale out more and more servers and up throwing it on the problem.
Yeah.
You need to do a beef scale up also, right? That's what this approach is about. So there are many players. There are few I know who are also into building specialized processors for that. So that also come and over time that you just like you have GPUs which started for graphics, but now for machine learning and deep learning. I'm sure there may be a room in the future for dedicated data processing units or whatever.
There are some other products I've come across. Like Meta has something called Velox. Is that in the same space as what you're doing?
It is in the similar space. Absolutely. Velox was think of like an answer from open source community to Databricks Photon, right? So Photon was never an open source thing, but there was a realization inside Meta that for their own workload, like Presto, they use that this is what I was telling earlier, that the journey from the evolution of the data platforms is from Java virtual machine based execution to C++, then to vectorize, and then you do GPUs and FPGAs, right? So Velox is that intermediate step, at least as of now, to provide a vectorized engine using AVX instructions or SIMD block of the processors to extend that, right? That is a one step. And obviously, I'm sure open source community is also thinking about how do you extend Velox to GPUs and so on. So that is one dimension of that. And we are kind of aware of that, as well as trying to not trying to be aligned with that initiative as well. Yes.
So what you're saying is Velox is mainly for SIMD, AVX, instruction set
Today.
on CPU, not GPU. Is that right?
Today, yes, that is
Today,
true.
okay.
But and there are early signs of Velox also trying to extend with that. And I don't want to use this to because I let
Yeah. No. Your job is
to
to talk about DataPelago. My job is to give the industry view. So
exactly. But there are just to
yeah.
because it's an open source community, we can talk about
Yes,
it. There's
we can talk about it.
initiative
It's open source. Yeah. It's also
Velox to
Prestissimo or something. What is that?
sorry, say that again.
Prestissimo. What
Yeah,
is?
that
Yeah.
was a project to put Velox as an engine for Presto, right?
I see.
That is just
Okay.
for specific to that.
I see.
Presto to Velox is a Presto
Yeah.
Simo. That's my understanding.
Yeah.
But what we are talking about is beyond Presto, right? You have
Yes.
Spark, you have
Yeah.
Trino, you have Flink, you
Yeah.
have many
Yeah.
other platforms or even proprietary ones, right? So it's not just that. I mean, there are other platforms. I'm just naming like Oracle is there, Teradata is there, or Snowflake is there, whatever, right? Those are all written with the infrastructure which existed earlier, some scale up or some scale out. So
Yeah.
all those platform need to be upgraded to this modern infrastructure, either through
Yeah.
UDP or some other way, right? But this is a common now.
So this is the last technical question I have, which is to your point. What are the future plans for DataPelago? What other engines and what other use cases do you have up your sleeve?
I think, I mean, you know better than me, Sanjeev. This is an ocean,
Yeah.
right? The data world is an ocean,
Yeah.
and it's evolving at very fast pace in multiple dimensions. So
Hmm.
let's touch those. One is your data itself is changing, the format and so on. Your applications are changing. What kind of processing you want to do for that data is changing. And the third is that they mention is that you have these multiple existing frameworks. You can go systematically go one after another and keep giving them the benefits of this new accelerated computing. And the fourth could be that, hey, I'm now enabling a new kind of application or whatever, right? So there are many dimensions that this it's a horizontal technology which we can do that. Okay, that's kind of one way. Now, from DataPelago point of view, we are a startup, Sanjeev. We are just at a so for in startup journey, you go from hill to hill. So we have the next hill to conquer. You have a fuel for that, and from there you go to the next hill, right? So that's how I look at the startup journey. So obviously, you can get very easily excited about all those opportunities. So the problem for us is what not to do rather than what to do. But there is an endless opportunities here to grow from there. So that's how we will see. We want to be in both in the brownfield world, helping enterprises save TCO, and also help the data plus AI world for the which is also very fascinating, as well as UDP and our technology applicable there.
So changing tracks as a founder, would you advise others to go on the same journey as you? What would be your career advice? Because you came from hardware into the data space. Some people are born in the data space. I'm just curious, what piece of advice would you give to our listeners?
I think, I mean, one is that there are two top parts of your question, Sanjeev. One is the domain itself. The data space is very, very exciting, right? I mean, I have done, as you said, infrastructure in the previous life, but data is now it's very, very relevant for enterprises point of view. You can extract insights. We used to hear the cliche data is oil. Now it is when you're getting value out of it, right? So that's one part. Then the second part is as a advice as a founder, I would say I'm still very early in my journey to be able to give advice to others. But it is a pretty it is a gratifying journey, right? Because you are making an impact at a small in your own small world. You are able to move the problem and so on. So hence it is satisfying, but it is a hard journey. I will also tell that. I mean, recently I heard Jensen. Somebody asked that at his peak of his career in the company, would you do the same thing again as a yeah? Even now, I think his answer was no. He will not do that because
Yeah.
the entrepreneurial journey is not easy, right? It's a hard journey. So I know we all of us want to do it, and plus a lot of another thing is there's a responsibility on your employees, on your shareholders, and you have the conviction that you can lead it. So you have to be very, very ready that yes, it cannot be a casual decision to do this journey.
So Rajan, last question. By the way, this is great advice. Yeah, people think, oh, it's a piece of cake. It's a 24/7 job, and it just never ends if you're an entrepreneur. Last question. Tell us something about what you like to do as a hobby, maybe outside the tech realm that most of the world does not know.
Yes, actually, honest answer, we get so busy in our normal life that you actually forget, at least that's where I am, like what is the what but still, I mean, you forget what you would want to spend because practically there is no free time, right? But there are some forcing functions that I use which force me to come out of my context. Maybe let me answer that way. One is obviously kids, their projects, or I coach them. I used to coach soccer or
Oh,
things for
wow.
kids. I coach them for robotics. So that also becomes a forcing function for me to come
Yeah.
out in. I don't know how good it is. When they make a mess of the robotics parts or whatever, I help clean up. And that is itself is therapeutic to me, right? It's a therapy that sorting those small parts itself
Yeah.
helps out of the con. So anything that gives me a forcing function to come out of the daily grind and then helps me come out is helpful. So kids, family, and then friends and going out. And area we are kind of blessed to have a lot of hiking trails and a lot of
Right.
beautiful
Amazing.
weather. This
Right.
kind of enables us, right?
Thank you so much. It's been such a pleasure, and you've opened us to this new realm of optimization of data platform and the entire history, because I really enjoyed how you walked us through your career and how you got to where you are today. Because unless we have that perspective of like the problems or the journey, it's very hard to understand what to do next. So thank you so much. Really appreciate it. It's such a pleasure.
Well, thank you, Sanjeev, for having me on your podcast, and it's a pleasure. It's my honor as well as pleasure to do this. Thank you.
Thank you. Thanks, everyone. Until next time, see you soon. Bye.